Hi there guys and welcome back to this course. So today I'm going to talk about shift register. How do they work and why are they important? Well, they're extremely important and you're going to see why in just a little bit. But first of all, let me just draw a shift register and then we're gonna basically talk about how it works and why it works this way. So a shift register is actually a series of D flip-flops like this. So we have the first flip-flop, D flip-flop with D as an input, Q as an output, and Q naught, which we are not going to use anyway. So the output of this one is actually passed to another flip-flop, which is a D flip-flop once again. So we have Q and Q naught, and then it passes the output again to another flip-flop. We have D, Q, which is the output, and Q naught, which is the inverse of the output. And then it passes to another flip-flop, like so. We have Q and Q naught. So let me just get Q3. This will be Q2. This will be Q1. And this will be Q0. Now we have a set signal and a clear signal. So set and clear, set and clear, set and clear. And the clear is actually connected to ground. So we have ground here, ground here, we have ground here again, whoops, yeah, and we have ground here again. Now, what we also have is the clock input. So we have the clock input into the flip-flop. So this is the clock, CK. We're just gonna go all the way to all the flip-flop, all the D flip-flop. So all the way to here, and also here, and also here, and also here. So remember, whenever you see this, it means that it's actually rising rising edge. So whenever the clock is rising, then it's gonna each component is gonna do something. If there was a knot here, like a little circle, it would have been that it would have meant that it was actually falling edge triggered and not rising edge triggered. So just imagine a rise. So whenever the clock goes high, so like whenever the clock goes high, and it's high here, and it's high here, and it's high here, and it's high here. Now, let's suppose that we have some kind of data as an input. So let's suppose that we have something like this. So we have something like 0 as an input. Well, no, let me just take it to 1. Okay, we have 1 as an input and then 0 as an input as our initial value, and then we have a 0 and a 0, and of course we get out a 0 from Q3 as well. So what's going to happen is that this one is actually going to get into this flip-flop as an input, and it's going to be transferred here. But notice that since they are, the clock is going to go on at the same time for all of them, this flip-flop is actually going to read 0 at the very beginning. This flip-flop is going to read 0. This flip-flop is going to read 0, and so on. So what's going to happen is that this one is going to go to here, and we're going to have this one here at the next cycle, so at the next clock. So it's actually going here, and we get 1. From here, the 0 is going to go, basically going to go here. It's going to be passed through here. So we're going to get 0 in the next cycle, the next clock cycle. So we're going to get a 0. Then D0 is going to be passed through here, the next cycle. So you get a 0 here. And then D0 is going to be passed here, the next cycle. So we get 0. So now, again, we go on with another clock cycle. So I suppose that we have got something else, like, I don't know, a new 0 as an input, okay, here. Then what's going to happen at the next clock is that it's still going to go on and on and on. So those are, you know, this one's going to go here, and 0 is going to go here, 0 is going to go here. So they're going to shift each time. So this 0 is essentially going to go from here to here. So we're going to get D0 here. And this one is going to go here. It's going to be passed through at the next clock cycle. So we're going to get 1. Then D0 is going to be passed through in the next clock cycle. We're going to get a 0. And again, D0 is going to be passed through here. And we're going to get a 0. So I suppose so now we are in the next clock cycle again, and we're going to get 1 once again. So if you get, I don't know, 1, oops, what did I do? A 1 here, then the same thing goes on and on and on again. So this one is actually going to be shifted here, and D0 is going to be shifted here, and this one is going to be shifted here. Whoops, I should have really used the red pen. Shame on me. So 1, and D0 is going to be shifted, so we get a 0. So you can see that at each clock, the data is going to basically pass from here to here, and next clock from here to here, and next clock from here to here, and next clock from here to here, all the way down to the final output. So, okay, why is it so useful? Well, it is indeed useful because it's basically shifting the bits, and you can actually shift in both directions. So you can shift to the right, but you can actually shift to the left. So what happens when you shift to the right? Well, if you shift to the right, then you're basically doing a very important operation in Boolean algebra. You are dividing a number. So you can basically shift to the right to divide a number, and you can shift to the left to multiply number. So going to the left, so shift left and shift right. So if we shift left, then we multiply multiply. If we shift right, we divide. So right, we divide. If we shift left, we multiply. So those are two very, very, very important operation in Boolean algebra because, so far we know how to do like basic stuff, but this way with shift register, we can actually do multiplication and division of number, and it's extremely useful. It really is. So again, shift register this is their implementation with D flip-flops, and you can either shift to the right or shift to the left. The meaning of shift basically means that whenever you get something in as an input, it's going to be shifted literally here and then here and then here and then here at each clock. So whenever the clock is rising, you can actually do that whenever the clock is falling. If you put a not here, not here, not here, not here, it's fine. But again, the important thing is actually that the data is going to be shifted. And if you shift right, you can divide a number in Boolean algebra. If you shift left, you can multiply a number in Boolean algebra. So this is extremely important. So yeah, that's pretty much it for now for shift registers. I hope it helps as always. So stay tuned for other video in this series. Bye for now.